My presentation today is about how bitumen emulsions or processes incorporating bitumen emulsions contribute towards sustainability by extending payment life and enhancing durability. The presentation uses examples of real case scenarios where savings on resources, financing, and emissions have been demonstrated. Some of the sustainability benefits of extending payment life when using surface treatments involving the use of bitumen emulsions include the reduction in the number of rehabilitation interventions that require removal and replacement of the pavement surface layer. This ultimately leads on to a reduction in the use of natural resources, saving them for future generations. Reduced emissions and traffic disruptions due to the speed of application and less use of plant and materials. Some processes will also renew friction and skid resistance to maintain safety, whilst others will additionally improve ride quality and surface noise. Bitumen emulsions extend pavement life in one of two ways: during construction or as part of a maintenance program. During construction, the emulsions such as bond coats and prime coats are used to bond between asphalt layers. Prime coats also help to bond granular layers before the addition of further asphalt layers. Sealing emulsions are used to seal the surface to maintain water balance on materials such as wet mix concrete base layers, ensuring water remains to maximize the concrete strength on curing. The main playground for emulsions, however, is in pavement preservation, where numerous processes are used depending on pavement age and condition. The treatments have been adapted globally to take into consideration local climate and traffic conditions. If we consider a full pavement with a design life of 30 years, there are a number of treatments which could be utilised depending on the pavement age and condition to help extend the life before the need for rehabilitation interventions. The earliest treatment applied would be a fog seal. The fog seal is typically applied when the pavement is 2 to 3 years old and the binder and the asphalt surfacing is still young. The fog seal binder can help maintain the binder's youthfulness, extending the life and reducing the early onset of surface cracking. A rejuvenating fog seal can be applied when the asphalt is a little older to add more life to the now aging binder. A third process which is used when the surface is older still is a mastic seal, which is essentially a fog seal or seal coat emulsion containing fine grit to also add some friction to the surface. When the road surface is around 10 years old, a chip seal or surface dressing can be applied just before the onset of visible surface defects. This will seal the surface to prevent water ingress and add surface texture to the more polished road surface. When the road surface hasn't been treated with surface dressing and some surface defects are visible, it can be treated using slurry surfacing or microsurfacing. Microsurfacing, due to its use of larger graded aggregates and polymer modified emulsions, can be used where some rutting has occurred while slurry surfacing can't. Scrub seal is a treatment process which involves application of emulsion by brush, which pushes emulsion into minor surface imperfections such as cracks before the addition of aggregates. The final treatment used would be a cape seal, which is a combination of surface dressing which is overlaid by a microsurfacing. The National Centre for Asphalt Technology (NCAT) currently have a long-term research study to quantify the life-extending benefits of various treatments, project TPF 5375. At the National Pavement Preservation Conference in September 2023, the findings were presented from the NCAT project to date. One of these projects was on a fog seal study monitored by the Minnesota Department of Transport. The test section is on the US 280 highway near Opelika. Early conclusions from the trial is that fog seal reduces the onset of early cracking, especially when used on newly laid surface, and increases the timeline for the appearance of 20% cracking to 8+ years. Another example for fog seal is a study carried out by Greenwich Council in London, UK in 2010. They investigated the benefits of fog seal on the 5 roads with different surface characteristics and defects, including newly laid surface dressing. The work was undertaken during the autumn months after the summer surface dressing programme had finished. The client was very happy with the outcome and concluded that the trial successfully demonstrated that fog seal can seal and reduce further oxidation to worn-out surfaces at minimal cost and minimal disruption to local residents. This slide, taken from the joint RSTA and REA report entitled The Case for Surface Dressing in the UK, outlines how surface dressing, when applied at the correct interjecture, just before the pavement condition reaches a stage where defects are visible, can be used repeatedly to extend the life by several decades. In this example, a surface course layer on a heavily trafficked road with an expected lifetime of 13 years is used as an example to demonstrate how its life is extended to well in excess of 40 years. This is achieved by repeatedly surface dressing just before the defects appear in the surface. In the UK, all classes of roads are surface dressed, including heavily trafficked trunk roads. The Association of Directors of Environment, Economy, Planning and Transport, ADEPT in short, formerly known as the County Surveyor Society, which produces policy guidance and specifications to the local authority client, work jointly with the Road Surface Treatments Association to produce a guidance document on the service life of road surface treatments for asset management purposes. The document, published in 2017, stated that surface dressing lasts up to 15 years on a low to medium trafficked road and 10 years on one with medium to high traffic. The vast majority of surface dressing in the UK uses polymer modified bitumen, and very little or no surface dressing is undertaken using standard penetration grade binder. There are different classes for degree of polymer modification to encompass the different road categories, climate and traffic volumes. As mentioned earlier, the Road Surface Treatments Association and the Road Emulsion Association published a report earlier in 2023 on the case for surface dressing. Some of the conclusions from that report stated that surface dressing uses 70% less bitumen, 80% less aggregates, and reduces truck movements by 75%, thereby conserving resources and reducing emissions. A presentation on the whole life cycle cost planning for sustainability from the RSTA compared a pavement which had been surface dressed 5 times over a 60-year life period versus one that hasn't been treated and had to undergo various mill and fill or other remediation. The report states that using surface dressing reduces costs by 70% and CO2 by 69% over that 60-year lifetime. Microsurfacing, a surface treatment which can be used when the road condition has surface defects such as rutting, making it unsuitable for surface dressing or chip seal. A long-term study on microsurfacing durability has been reported on roadresources.org. Highway 61 at Tunica, Mississippi suffered from friction loss, surface cracking and rutting from repeated pounding of 13,000 heavy vehicles per day. In 2005, 12 miles of the highway was treated with microsurfacing and was inspected again in 2020. The images on the right show that the surface remained in good condition in 2017. When inspected in 2020, the surface remained in good condition, demonstrating an increase in service life of 14 plus years. A statement from the district engineer from Mississippi Department of Transport said that having this surface treatment lasting almost 15 years has enabled them to reallocate the $3 to $4 million they would have spent on mill and fill by a factor of 2 or 3, which is potentially a saving of $12 million. My final example is for Cape Seal, which can be used on older, more deteriorated road surfaces. Cape seal is a combination of surface dressing or chip seal, which has a layer of microsurfacing applied on top. The town of Lexington in Massachusetts has had a policy of mill and fill or crack sealing its streets for years. In 2016, they decided to initiate a program of using Cape seal as a treatment. Grove Street in the town contained a lot of cracking and ravelling from the pounding of 10,000 vehicles per day of traffic. A decision was taken to treat 21,867 square yards of carriageway with Cape seal. After only 2 years, the town engineer concluded that their Cape seal program had the net positive benefit by adding 60 mile years of life to their network. In conclusion, the use of bitumen emulsions for extending pavement life has been demonstrated to offer the following benefits using real-life examples. The benefits include extending life by 60 mile years, freeing up to $12 million in funding to use on other projects. Using surface dressing reduces aggregate use by 80% and truck movements by 75%. Surface dressing repeatedly to increase the road lifetime up to 60 years can reduce carbon dioxide by 69% and cost by 70% compared to standard mill and fill. The use of fog seal delays the onset of 20% surface cracking to 8+ years. The information and case studies mentioned in this presentation can be found using the following references. I have now come to the end of my presentation. Thank you for listening.